Hello, folks. Anthony Crane here with Pocket Coach. I'm starting my 5-minute timer. And today we are going to talk about an experiment called fast estimation. So here's the experiment page for this one. The problem we're trying to solve with fast estimation. We used to use planning poker like most people, but we found that most of our teams were only estimating about 8 stories an hour. And there was a lot of stories to be estimated. So this was not scalable for us. It was so slow, it led to many stories not having estimates at all, which was also not helpful for us to use metrics to understand our flow. So the hypothesis is that fast estimation is a working agreement that allowed us to estimate as many as 40 stories per hour with no loss in sprint accuracy. So we have the same accuracy, but now we're doing 40 stories an hour. That sounds like a win. So we think we show other people the fast estimation, and maybe it'll accelerate you as well. Time frame, 2 hours, right? In your next estimation session, try it out. You'll know right away whether it's working for you. Typical outcomes. You should decrease the time to estimate stories, as you see above, and decrease the number of stories without estimates to 0 because it's so darn fast that when you create a story, you also estimate. Skill growth. So in other words, what do we have to do to execute the experiment? You have used the fast estimation working agreement and we're able to estimate more stories per hour than before. Very simple. So this is one of the easier ones to get through as an experiment. So let's get into the materials. So we have here the relative estimation deck. Now, fast estimation assumes you already understand relative estimation. So if you don't, please go watch our relative estimation video, which we've already shot last time. And so now you can build on that with the fast estimation. So I'm going to skip to the fast estimation part here. So how is fast estimation different than relative estimation? It's faster with no loss of quality. So we have a North Star here. To never have a feature or initiative that is unestimated and to maximize the speed without losing quality of the estimates. So here is part of the working agreement. Okay, so we ensure that everyone actually, this is the full working agreement. We ensure everyone has a voice. That's normal. The PO participates. Now, a lot of estimation guys tell you that they can't participate. We absolutely want them to participate. If the PO thinks it's huge and we think it's small, there's a knowledge gap. If the PO thinks it's tiny and we think it's huge, again, there's some kind of a knowledge gap. Either we don't know, the PO doesn't understand technology, we don't understand some requirements, something. So having the PO's voice in that room can often shed massive light. So in this case, we're going to sort work item smallest to biggest. Not everybody does that, but many people do that. Our smallest work item is a 1, so that's pretty typical for those who sort. And then, as always, we do 1, 2, 3 vote. But we use our fingers and cameras. We don't bother with cards and apps. It's a 1, 2, 3, 5, 8. Okay, for 13. Yep, easily done. Then what's that? What's next? 20. So there's your 20. And then what's next is 40. If you believe in 40, 60. Sorry, 40, 60, 20. Yeah, 60. That's my little 6 and 0. 6 and 0. There we go. 60, and for 100, we just do this. Okay. So anyway, that's the we used to use our fingers for all the numbers that we need to throw. And then here's where it gets pretty fast. If everyone's the same, you're done. That rarely happens, but if it does, you're done. If you are only 1 Fibonacci spot off, so in this case, a 3 and a 5, that's 2 numbers off, but it's 3, 4, 5, but there is no 4. So you're 1 Fibonacci apart, 3 and 5. Just pick the higher and move on. Don't discuss it. In planning poker, you discuss everything. And guess what? We're just trying to load up an iteration here. So we don't need to discuss everything. We can save that for the actual iteration. As long as we're 1 apart, just round up and load your sprint. If you're 2 spots off, in this case, 3, 5, 8, right? So those 3 numbers off, you pick the middle. So in this case, if you had some 3s, some 5s, and some 8s, you pick the 5. Again, if someone's passionate about that 8, if someone's passionate about that 3, they can still speak up. But understand that we're talking about a couple of point difference. And so when it comes to loading the sprint, it's not really going to have that big of an effect. So they agree to go fast and because we're going to refine these estimates sometime in the future. So that's the working agreement. I'm seeing I'm almost running out of time. So for the second 5 minutes, what I'm going to do is show you why this agreement is so powerful and why it works. So if you want to stick around for an extra 5 minutes, that's what we'll cover. Otherwise, have a great day. All right, moving forward then. Why do we focus on faster estimation? Because this way, everything gets estimated. And we're not looking for exactments, we're looking for estimates. Will quality suffer? So no, it has not shown to suffer. What we found is that the sprint say-do ratio has been the same whether we use fast estimation or planning poker. And in fact, the biggest factor in bad estimates are new teams. That's why you don't want to change teams a lot. New teams tend to estimate worse. All right, I'm going to reset that timer for a final 5 minutes. Here we go. Okay. So a couple things. One, we didn't used to have points. It used to just be how many stories can you load in the sprint based on gut. So if the points are a couple points off, it doesn't matter, right? We were loading on gut before. Now we're loading on something a little more refined. So if it's a Fibonacci point off, who cares? The other thing is t-shirt sizes. Some people like to use those. We don't like those because they're fast, but you can't add them up. So you can't load sprints by mathematics with a small plus an XL. What's that? Unless you have some kind of mapping, in which case you may as well use Fibonacci. So with the Fibonacci, this gave us a lot more sizing, kind of like, oh, that's a bigger one, that's a smaller one. But now people took it too far. People are putting way too much energy into these numbers when originally we were just all ones or all t-shirt sizes. Don't overthink it. And that's why we came up with the working agreement. Continuing on here, you can see here some data. We actually did this with a bunch of teams. And so you can see here with these 8 teams that we tracked, we've done it with a lot more than that, but these were the first 8 we ever did. You can see that stories estimated per hour. Ants kit, that's what it used to be called before we called it fast estimation. But you can see the ones who did fast estimation 30, 30, 40, and 25. Those who were using straight up planning poker 5, 3, 5, 5, 3, 4. And then in terms of accuracy, check this out: 90%, 90%, 85%. This team here only had a 50% accuracy, so they didn't do so well. With planning poker, we had 77%, 90%, 75%. And teammate had their own estimate style, and they only got 4 stories done, but they were 80%. So overall, it had much more to do with how mature the team is than which technique they were using. So if that's true, if all of them have equal quality, then the one with the highest productivity might be the one to go for. By the way, this is an example of how you run experiments in general. You come up with factors you can measure, run the experiment, look at the metrics, right? So we were pretty excited to also show this as an example of using metrics to validate experiments. One question that comes up a lot is, when do you estimate? The minute you create the story, we estimate it. We also estimate it when we're loading a sprint. Okay. And if we do story refinement, some teams do it, some teams don't. If you do story refinement, you can update it then as well. So you create it on refinement, on sprint loading. Those are the 3 times. So there's plenty of times where you can update the estimate. So just because we estimate it once doesn't mean we believe it later. Last thing I want to point out is that there are 3 stages of fast estimation. For a new backlog, it's going to be your slowest version of fast estimation, and yet they'll still be fast. If you have an existing backlog, but you have some new team members, remember that somebody's going to cause a dip, and it's going to be faster than a new backlog, but slower than a stable team. And finally, C, this is if you have an existing backlog and a stable seasoned team, that's when it's like lightning fast. So what happens if you have a new backlog is that you have to sort everything, and then you have to figure out what your one is, and then everybody negotiates a lot more. So your new backlog, new team. For B and C, however, once you get to B, it's interesting because someone will come in and say, hey, can you guys add this to that, right, in the software? Or can you implement something that does this or that? And we write it down and we're like, yeah, that's like an 8. And people are like, 8 what? We're like, oh, it's an 8 relative to other 8s, right? But like culturally, our team just looks at a piece of work and says, yeah, that's an 8. And it's rare that we disagree. And if we do, it's because somebody thought of something the rest of us didn't. So it's really fast because now we're no longer relatively estimating to a list, which is what you do when you're an A. In B, you're really estimating based on your own experience. And that only happens when you're stable, when you have a stable backlog. So much, much faster. And then C, the problem with B, by the way, is that if you have new members, they're going to be like, 8 what? What are you talking about? It's an 8. So you're going to have to open up your tool, look at some historical 8s and say, see all these? We think it's about as hard as these. Show the 5s and the 3s. You're like, I think they're easier than this. And throw the 13s and 20s. And you're like, it's easier than these, right? So you have to actually show your new people the history in order for them to get the hang of it. With C, all the members are experienced, or it's a stable team, current backlog. Now you just walk in, someone mentions a piece of work and you're like, that's a 3. You point it, you throw it into the backlog, or you throw it into a sprint if you do that rolling wave planning kind of thing, forecasting or something. But in the end, that's the 3 kind of phases, if you will, of fast estimation. So there you have it. That's fast estimation in 10 minutes. I hope you find this video useful. Try it out as an experiment. It really helped us quite a bit. This simple little working agreement has really accelerated our teams. So I'm Anthony Crane. Thank you so much for your time, and I'll catch you on the next video.